It's an ordinary day in late 1700s Germany. In a small classroom, a young boy sits near the back, among rows of wooden desks, pencil in hand. His teacher stands at the blackboard, fingers dusted with chalk. "Add up every number from 1 to 100, the teacher says, expecting the room to stay quiet for the rest of the lesson. The classroom goes quiet as the students settle into the task, pencils moving across their slates. But within just a few seconds, the boy sets his down. He already has the answer. That boy grew up to become one of the most influential mathematicians in history, someone whose discoveries are still used in mathematics today. Carl Friedrich Gauss.
In this video, let's find out exactly how he did it. Here's the challenge: 1 plus 2 plus 3 plus 4, all the way up to 100. Try pausing the video here and thinking about how you might approach this. Then press play whenever you'd like to see the solution. Let's work through it together. Instead of adding the numbers one after another, 1 plus 2, then 3, then 4, Gauss started from the two ends of the sequence. He began by taking the first number, 1, and adding it to the last number, 100. That gives us 101. Then he did the same with the second number and the second to last number, 2 and 99. Once again, the result was 101. He tried it once more with the third number and the third to last, 3 and 98. And again, 101. It quickly became clear that every time he paired up the numbers this way, moving one step in from each end, the result was always 101. So the question became, how many pairs are there in total? To check this, let's look at the middle of the sequence. The middle pair is 50 and 51, and as expected, that also gives us 101. Since the number 1 formed the first pair and 50 formed the very last pair, that means there are 50 pairs in total. Now each of these 50 pairs adds up to 101. So to find the total, we simply multiply 50 times 101. That gives us 5050, and that's exactly the value Gauss worked out in just a few seconds. His teacher was amazed by the correct answer, but that's not the end of the story. It turns out this same method doesn't only work for the numbers from 1 to 100, it works for any sequence of consecutive numbers, starting from 1. We can write this as a general rule: n times open bracket, n plus 1, close bracket, divided by 2, where n is the number of values we're adding, starting from 1. Let's check that this actually works. Let's try it with n equal to 100. Substituting n with 100, the formula becomes 100 times, open bracket, 100 plus 1, close bracket, divided by 2. That's 100 times 101 divided by 2, which gives us 5050, exactly the number we found before. This formula can always be used. Now it's your turn. Try adding the numbers from 1 to 10 using both methods, with the formula and without it. Pause the video here and give it a go. Then press play to check your answer. Without the formula, adding the numbers one by one gives us a total of 55. Now let's apply the formula. With n equal to 10, we get 10 times, open bracket, 10 plus 1, close bracket, divided by 2, which is 10 times 11 divided by 2, and that also gives us 55. And that's how this trick works. Some of you might already have known it. If you didn't, I hope you found it useful. Let me know in the comments if this was new to you. And if there's a topic you'd like me to cover next, feel free to leave a suggestion there too. If you like this video, please give it a thumbs up and consider subscribing to the channel. Thanks so much for watching, and I'll see you in the next one.